we are. Good afternoon again, and welcome to our workshop. We are recording for YouTube to support others who can't attend today. And this is for the KCL Space Hackathon next weekend. And my name's Mark Howie, and Rob Webster is here from GSI. And we'd like to help everybody understand the challenge, understand what we're looking for, and if there's any particular technical challenges, particularly around the use of remote sensing data and geospatial data, we're here to help with that today. So, as I say, please generally keep sound down and submit questions on chat. At the end of today, we will be helping KCL Space. We'll forward the slides as PDF. As you'll see, there's lots of URLs, things you can look up, tutorials and tools that you can look up and use to help you next week. We'll also be submitting the video for YouTube as well. And I believe that will go on KCL Space channel as well as our own channel. So what we hope to go through today in the workshop is really an introduction to who we are as a company and why we're interested in climate change, why we're interested in change around natural resources, and what our experience has been. And in particular, looking at Storm Arwen, which happened at the end of last year. I'll hand over to Rob at that point, who will present some background and supporting information around use of geospatial data and satellite data, and thinking ahead towards a commercial presentation, which is part of the challenge as well. And then we'll get through to questions towards the end. Okay, so Global Surface Intelligence, otherwise known as GSI, actually came out of University College London a number of years ago through PhD theses students, and has grown to be a team of about 15 people at the moment. So we are classed as an SME. We focus on climate smart natural resource management. In particular, we have a strong history around forest measurement, forest inventories, and also land cover classification. We have patented technology in the application of machine learning to satellite data, in particular time series of satellite data. Now, the strength there is thinking about natural resources and their colour changes throughout the year. That's correlates well with time series of satellite data. So our production team, our whole technical team has a mixture of skills to support this. We've got remote sensing specialists, machine learning, data science, environmental science, and experts in HPC computing as well. And it's only through all of these that we are able to deliver our products and our services. In the last 3 years, we've grown in strength in business, particularly in North America, and understanding the forestry industry there. Obviously, our technology has applications to crops, natural, and anywhere where there's natural or managed plants or trees. But we've got a specialization in forestry, and we are in the process of transferring that knowledge and applying it to Europe and other parts of the world. So please get in touch if you need. You can obviously find myself and Rob on LinkedIn, but there's also a direct email there at the bottom of this slide. So I've got a couple of examples here of the work that we have been doing in the last year. I think are very good examples of our capability. So we've recently completed dataset for something called the Forest Mind project. This is funded by the European Space Agency at the moment, and it will be heading to a commercial service later this year. We are one of 9 partners, some mixed academic partners, non-governmental bodies and private partners. And the goal of Forest Mind Service is to look at the risks within supply chains, particularly for food commodities to UK and European shops and the common members of the public. So to understand whether your chicken that you have bought, if there's some deforestation involved in the production of that chicken. So if you think of deforestation, particularly in Brazil, and you think of soy and the massive amounts of deforestation in the last several years, 10 years, around soy production, that soy is often then shipped to the UK and used for chicken or for pork feed, and that ends up on your plate or on the shelves of the supermarket. So to support that, there are many different technologies applied. GSI has recently created a land cover classification at 10-metre resolution for 2 years to demonstrate a history in the change between 2017 and 2020. And that area covers the state of Mato Grosso, as you can see in the image there. So that's 134 million hectares, and our data set has over 13 billion pixels, so it's an incredibly large data set. And that data that we've provided will now be combined with other deforestation data, commodity trace data, supply chain analytics and interpretation, and hosted on a platform to provide a service for clients. So that is an area of real stress at the moment, regulatory stress, and obviously there are elements of environmental stress there as well. So that's an example of very, very large scale data that we're able to produce globally through the application of our tools on satellite data. As I mentioned before, our key strategies are around forest measurement and built in North America. I've got a couple of examples on the screen now. So think about time series analysis, as I mentioned, and the color changes. You can obviously tell the difference between a deciduous tree and a broadleaf tree, but you can also tell the difference between individual species. And you can also get a good correlation with size and tree density, so the number of trees within an area. And from there, we're able to develop products using various methodologies. And these products may be more forestry aligned, so identifying individual stands, which would be areas of homogeneous forest, looking at derivative products such as timber volume or carbon content. Typically, we work with open source data. We can't see every single tree, but we don't need to. We get extremely good results in a way that's not been possible before. And this is an area of real growth as well. We consider ourselves to have one of the best technologies out on the market. And as I say, applications across North America, Canada, United States, and recent work in Scotland and other areas of Europe as well. Okay, so what's the challenge for next weekend? Well, the challenge is to detect storm damage to forests using satellite data and to present this as a commercial service. We're asked to provide both a hard tests on hard skills and soft skills, hence the two elements to that. The balance, but how you apply yourself to both of those elements is up to every team, of course. And we know this is a challenge. We know this is this real interest here. very much a topic of discussion within forestry, but it obviously relates to climate change as well, and the growing disruption that comes from climate change. So we are offering the winning team, all members of the winning team, to go through a selection process for a paid internship this summer as well, to come and join our production team and engage with us in a commercial environment and learn and be part of our team and part of our company. So a prime example of this actually is Rob, my colleague here, who was an intern for a good many months, and on graduation joined our company as well. So the mentors, so next weekend, 3 of us will be supporting the workshop next week on a rotation. Sometimes there may be 2 of us, typically up and working between 9 and 5:30, covering both days, Saturday and Sunday. So there's myself, chief engineer, so I look after all the operations within Global Surface Intelligence, making sure that we have the team, we have the technology to deliver what we say we're going to deliver. Very involved in both sales as well as the creation of the solution and managing the team. So my colleague Rob here, geospatial data scientist with a background in GIS and geography, has strong skills in coding and managing complex spatial data. And Stuart McCallum, who cannot join us today, is our remote sensing expert and technical lead, and he will be around for much of next weekend. So thinking about the challenge and really climate change and the effects on forestry, you know, there's a number of different aspects to it, and I will go through this very quickly. So we can think of 2 different types of effects from climate change. There's direct and indirect, and here we might start with the indirect, which we might call biotic damage. So biotic damage through not through the weather directly, but through changes in patterns which allow diseases and insects to damage trees, damage whole forests. So the growth, the change in temperature, typically a rise, the change in rainfall, either a drought or more moist, allows these diseases and these insects to spread. And we see large areas across continental Europe affected by these problems, particularly the bark beetles. That's partly brought around through stress on the trees, through drought. And in this country, we have something called Phytophthora ramorum, which is particularly sensitive to climate. So it thrives in 18 to 22 degrees centigrade and moist conditions. And that becomes more common, and that has become a more common disease that will kill trees in this country. Thinking about the abiotic damage, obviously, we're talking about storm damage today, but there are other aspects as well. There's drought, and there's large areas of beach killed by drought in continental Europe. So on to Storm Arwen. So Storm Arwen happened on 25th, 26th, 27th of November last year, with 2 other storms that followed within the weeks shortly after that. It affected Scotland and the north of England, so mostly eastern Scotland and the south of Scotland, and then the north of England. Large areas were destroyed, large areas of forest were destroyed. There were initial reports that the timber that comes from the trees, there was twice as many trees as would normally be harvested every year were killed in that one storm. So twice the annual harvest. That obviously placed huge stress on the resources to clear that up, That's the machinery and the people, the lorries, the mills and everything else. But also potentially changes the way that the land can be managed. I think it covered approximately 1% of the total area of Scotland, somewhere in the region of over 6,500 hectares, I believe. It affected over 1,000 forest owners. All of that broken wood, had broken trees, the dead trees, the torn up trees had to be located and to be harvested safely in a more extreme environment than where we have a standing tree and a forest of entirely standing trees. A normal harvest situation. These are far more dangerous operations. Those had to be recovered, taken to mills, but also thinking about what happens afterwards. Replanting an area is very, very important. If you did not know where the trees were, if you did not know where the storm damage was, you would not be able to plant on that area. If you left it for 2 years, the timber would start to rot, and it would be very, very hard to remove the trees, which would allow you then to replant that area for some time. So it's a loss of the area in terms of forest management. In terms of how quickly you can take the trees out and use the timber, typically something like spruce may have up to 18 months in which you can leave it if it's attached to the root, and you can still recover it and take the timber from it. But something like pine, which is very common as well, it must be cleared immediately within weeks, certainly within months. Something called blue stain, which is a fungus, can affect the trees, can also affect the timber, can spread from one piece to another, and makes the timber and the trees unmarketable. So it's very important to be able to harvest as quickly as possible and to make sensible decisions around what to harvest. So outside of Storm Arwen was a particularly large storm. If I just go back here, something I wanted to mention on the size of this storm. Whilst you can't prove a correlation between the size of the storm and climate change, there's a sort of growing confidence statistically in the relationship between the two. So typically they would talk about large storms every 10 years and very large storms every 50 years. We know we've had large storms in 68, 87, and now 2021. So it does appear to be a growing shift towards large storms in this country in particular. Even with smaller storms, there is a need to find storm damage. So the reason for that is several, really. If you are managing a forest, you have a commercial plan for that forest, you may have insurance on that. You're unable to claim on that insurance unless you know there's damage and can prove that there is damage. But how do you know there's damage? How do you know where the damage is? It's often hidden. It's often within a patch of trees where the outside may be green, but inside there may be some trees that have been blown down. So it's hard to see unless you walk every piece of forest, and that's an impossibility on large estates. Only once you've found that blowdown can you harvest it and recover it. So if you don't know it's there, you can't respond. So one of the reasons why Storm Arwen was particularly damaging was because the winds were from the north. Typically the trees in this country are used to winds from the west, and they are strong and can withstand winds from the west very well. But with strong winds from the north, they are less resilient, and hence why there was so much widespread damage. So I hope that gives a good introduction to who we are and what we're doing here today, and really some context around the challenge that we've set for the hackathon. I'm going to invite Rob now to talk about the geospatial data. To you, Rob.
Yeah. Thanks, Mark. So Mark's given a sort of introduction and a bit of the context. So I'm just going to take a look at the kinds of data that we work with at GSI and that you may want to work with, or you may end up working with on the hackathon. So we primarily work with geospatial data, which is to say any data that has a kind of location or geographic information attached to it of various types. And within that umbrella term, geospatial data, there's two main classes, vector and raster data, and we work with both. So vector data tends to be these three types: points, lines, polygons. Points are literally just a pair of coordinates, and then from that building block, you can create lines and then polygons. And for real world context, points may describe the locations of cities. Lines might be something like a river network or a road network. And then polygons are used to describe areas. So it could be states of a country, or the outlines of cities or areas which have been storm damaged. And then the other type of data, main type of data, is the raster, which is basically like an image, like a normal image, but with this additional geographic information attached to it. So it's gridded data made up of pixels, and each pixel will have a single number associated with it, a single value. And then together with that grid of information, you'll have your location information, which maps each pixel onto the actual Earth surface, onto the real world. So the form that location information takes is usually in the form of coordinates, and then some kind of CRS or coordinate reference system, which is a way of interpreting those coordinates with respect to different, in different ways, depending on where you are on the Earth's surface, basically. Mark, could you go to the next slide, please? So again, within the geospatial data framework, we work at GSI with Earth observation data, which is basically for us means satellite imagery, satellite observations. So there's huge numbers of different satellites flying around the Earth at this moment, and they make observations with different types of sensors in different ways. You may have optical sensors, which are like photographs, or radar sensors, or microwave sensing sensors. So there's a full range, but and some of that data is open source and some of it is commercial. At GSI, we primarily work with the Sentinel-2 constellation. It's actually 2 different satellites, and that is operated by the European Space Agency, and all the data is open source, and you tend to get a new satellite image over a given part of the Earth's surface every week, roughly. Sentinel-2 is an optical sensor, so it takes imagery like a normal camera would, but with 13 bands instead of the normal red, green, and blue. And each of those bands is basically a photograph taken looking at a particular set of wavelengths, sort of targeted wavelengths, out of which, and each of those wavelengths kind of, it goes up from the visible spectrum and then up towards the infrared. And with that wealth of information from all these different bands, you can kind of extract different types of information about the Earth's surface, or the surface, whatever you're looking at with the satellite. And we'll send out this PowerPoint presentation to the people present afterwards, and some parts of it have links through to more information about different parts of what I'm talking about. So, but for the basics, kind of, we can extract. Well, in the case of Sentinel-2, if you extract bands 4, 3, and 2 from the 13 bands, then you can put those together as an RGB, so a true color composite, just like a normal photograph, and it might look something like this. This is looking down at a glaciated island, and the sea around it with some cloud here. But you can also analyze the other bands and visualize those in what's called a false color image, where you put a band that's not necessarily the red band into the red color channel of an image. In this example here, I've put the near infrared band into where the red usually goes, and using that method, you can highlight things like vegetation, which are very reflective in the near infrared band. And in this little example here in the bottom right, the red areas are vegetated areas. And there are lots of different ways of combining these 13 bands to access or to highlight different features of the ground, or the Earth's surface. And they can be very useful when you're wanting to focus in on a particular type of, say, damage, or a particular crop, or a particular type of forest. And these are referred to as spectral indices, and usually there's some combination of different bands combined in such a way as to, as I say, pop out different features on the ground. Next slide, please. So yeah, as with everything online, there's an enormous set of resources. I've highlighted just a few here with these links to get started if you've never worked with this kind of data before. And they're particularly focused on Python, but of course you can use whatever language you want to in the hackathon. But in GSI, we mainly work with Python code, so the examples tend to be Python. So we've got a tutorial loading and working with some raster data, loading and working with some vector data. The Sentinel Playground is just a very nice interactive web app that allows you to quickly load satellite data for any part of the world and just have a quick visualization of the various bands and how you can combine them to bring out different features of the Earth's surface. And this Rus Copernicus is a sort of educational outreach from the European Space Agency, and they have a lot of very helpful YouTube tutorials going through what's possible with satellite data, all open source data, for various real world applications. So I would recommend looking at some of those links. Next slide, please. In terms of working with the geospatial data during the hackathon, there are again myriad options, but they more or less break down into, you've got the graphical user interface tools, and then you've got the code-based or command line tools. I'll just mention 3 of the key GUI tools. QGIS or QGIS is an open source GIS package for visualizing raster and vector data, and it's hugely powerful for exploring geospatial data. free to download and install for multiple platforms. And Snap is, again, open source software from the European Space Agency that's designed for loading, manipulating and visualizing satellite data such as Sentinel-2 data. And we will be providing Sentinel-2 data for the hackathon. So that can be useful for exploring the data as well. I've mentioned ArcGIS here at the bottom. That's kind of the industry standard GIS, graphical information systems package. But unless you happen to have a license for that, then you won't be using that on the hackathon as it's not open source. And yeah, the screenshots there, that the one on the top right is QGIS and the bottom right is Snap. Next slide, please. So in terms of, we'll come to it, but one of the challenges of putting together products in this space is that you want it to be able to be as automated as possible in order to make it scale. And therefore, you'll be working with the data in some kind of code, some kind of software that you'll be writing. So in terms of working with this kind of data in Python, there are various libraries which are very useful for loading in vector and raster data into Python. And I've just mentioned two of these, but again, there are loads of them. These are the two of the simplest and most often used. GeoPandas, which is built on the well-known pandas library, which is for working with vector data, and then Raster.io or Rasterio for working with raster data, i.e. satellite images. And then once you've loaded in your data with these and manipulated it how you want, then you can also use a lot of the standard Python libraries for working with this data. So NumPy, Pandas, Matplotlib for doing calculations, working with large data sets, visualizing and exploring your data. And of course, you can use any other language that you would like, and if you're more familiar with. I've got a little screenshot at the bottom of this slide of importing some data using Rasterio, but that's taken from a notebook which I'll make available to people, so you can actually step through and look at it more closely. Next slide, please. The problem of where to do your computation will arise. In terms of the hackathon, you'll mostly be working with a sort of range, a quantity of data that's handleable on your own laptop. So there should be no problem running a lot of the analysis on your own laptop. But of course, if you want, you can make use of some of the really good cloud computing resources that are available now, such as Kaggle and Google Colab, which are both, if you're not familiar with them, are both basically built on top of Jupyter notebooks. And yeah, it's a really good way of sharing the work that you're doing, and if you all want to work on the same project and don't happen to be co-located. And I've put together an example Kaggle notebook, which you can access at this link here, which kind of is a mixture of basic explanatory text plus just showing you how you might load in and explore some satellite image band data and some very basic vector polygon data as well, and how you might work with those together. And both of those skills are going to be really key, I think, for any implementation of an algorithm. Yeah, we'll move on. Next, we come to kind of tools that you might want to use for the actual forest change detection itself. And again, I won't go into detail on machine learning tools in Python because there's a myriad. But if you're not particularly familiar with this area, then scikit-learn, which is I think the most common, most popular Python machine learning library, is a good place to start. Lots of other ways to do it. Lots of literature, and you'll probably want to be looking at literature for just to get some idea of how others have tried to solve these types of problems in the past and where you might start. Just on the right-hand side of the screen here, I've just broken down kind of the three main parts of the approach to machine learning, I guess. So or at least supervised machine learning. So you start with some kind of training set creation. So some information that gives some real world knowledge to the model so that you can try and train a machine learning model. And then a couple of different machine learning algorithms, random forest, support vector machines, which are both ones which have been around for quite some time. And again, there are many, many others. And then once you've implemented a model of some kind, then there's the stage of model validation. How good is your model, and where does it not perform well, and where might you want to come back and revisit your training set and improve it, and then come back through the process. If we go to the next slide, please. Just a couple of examples again, which some of these types of things are covered in that Kaggle notebook that I linked to earlier. But in terms of analysis of your data, you can make use of Python standard tools such as matplotlib for visualizing, things such as a histogram of the various values of your different satellite image bands, and from that you can identify differences between different bands that you could exploit for a particular purpose, for example, or just to generally get a feel for your data. So those kind of tools are very, very, very handy. On the left, there's an example of a confusion matrix, which is, again, a standard visualization tool for assessing how good a machine learning algorithm is, and pointing out ways in which you might want to improve it. And again, yeah, there are plenty of other analysis tools you can use in Python. So we go to the next one. So I guess the core of the hackathon challenge is, once you've kind of gotten familiar with some of the data, is how are you going to actually use that data to detect what you want to detect? And as with anything, there's a million ways to do it. And there's some examples here, which I won't go into in depth or even slight depth, because it would take a long time. But it's just some examples of places to start. The very basic level, you've got thresholding, so you might say in a particular band, anything above this value is such and such, and anything below that value is something else. You can separate out the information in bands that way, and then from that most basic method, you can go up into all the complexity that you like, really. And the most complex is not necessarily the best. So you might want to try several different methods if you can find the time and compare them. Next slide, please. So the keys to success, Mark alluded earlier on to the kind of hard skills and the soft skills, and the fact that the challenge is wanting you to look at both of those. So there's the section of the product which is actually doing the core detection of the problem, the issue with the blowdown in this case. And then there are related aspects such as how do you know how good your model is? How well does it perform in different scenarios? And what are the limitations of the method? And again, how it may well work very well in a small test area, but could you scale it easily to cover the whole of a country or the whole of a continent or the whole world? And does it scale temporally, meaning how quickly can you detect the change? Are you detecting change on an annual basis, or can you do it on a weekly basis? And the difference between those approaches is obviously quite large and could be very important. And then there are the more commercial aspects. So I think Mark might be better placed to just go into that a little more. So hopefully I've given at least a broad overview of some of the data related topics. And I'll pass back to Mark.
Thank you, Rob. Again, folks, if you've got any questions, please put them in chat for just now, and we'll have a look at those towards the end. And so thanks, Rob, for looking through geospatial data. I think one thing we've maybe not covered is what you can expect next weekend. So for 9 o'clock on Saturday morning next weekend, we will be providing a selection of satellite images and with geospatial information within them, but also CSV files, so text files, which contains everything else, all the pixel values, but without the geospatial data. So you've got two choices there. I think you can approach it from a proper map view, top-down view, or you can just simply look at numbers and trends in those numbers and completely ignore the spatial context and the way the pixels relate to each other. So I think that's an important choice. We intend to provide data for one area over a period of time. That's before and after the storm. So it is possible for you to detect that change, obviously, and we will be, I believe, providing the locations of the storm damage for some of the area. And I think the challenge there is, how can you scale that out? How well does your model perform in other areas? So moving on to the commercial side. So part of the challenge is really thinking about how can you flex your soft skills, and how can you take, you may have the best solution in the world, but if you can't present it well, it's you're not going to engage very well in the commercial environment. So we need to give you a little bit of a challenge around that. And so really the idea is it's fairly loose, but a commercial presentation. So thinking about not just showing it in a sort of professional manner, but thinking about what would a commercial service look like. Now you can build quite a lot of it, architecture and presentation around this, so we can keep it fairly slim, but we will be assessing this element as well. So thinking about who the users are, how they're going to access it. Is it going to be on the web? Is it going to be through notifications? Is it going to be emails? Is it going to be on apps? Thinking about what else they can combine how else, what other data sets can be combined with the storm detection. So you may want to overlay weather predictions, you may want to overlay license data or cadastral data, which is around land ownership. You may want to put on regulatory information. And then thinking about what other services a commercial proposition or a commercial business might combine with storm wind damage detection. So for instance, you might think about how would you respond to that damage, and offering the landowner some way of responding, maybe a financial service, or something around a ground survey or a LiDAR survey from drones, or maybe simply high resolution satellite image. So there's a number of different things and different directions you can explore with the commercial side. But I think at the very least, we would be looking for teams to present their solution in a professional manner, and the strength of that solution, and in a professional, slick manner. And I guess in terms of format, I am not actually sure if KCL Space have any restrictions on that, but I'm suggesting possibly posters, videos, web pages. Over to you guys on how you want to approach that. So I think that's the end of our presentation today. As I said, we've recorded this. It will be going on to YouTube on KCL Space channel and our own channel as well, I believe. And these slides with all the URLs in there, including the Google Colab that Rob set up. It's all there for you to explore between now and next Saturday. I think it's a really exciting challenge we've set for you, hopefully very engaging and very much about what's happening now in the world, and how these technologies can make a real difference now. So, just wondering if there's any questions there in chat. So will we get a recording presentation? Yes. On YouTube, I'll be posting to KCL Space Fedor later on today. Is there an organizer email contact? So I believe actually during the hackathon, Saturday and Sunday, I think we're using Discord channels to be live. So we'll have somebody live covering 9 to 5:30 on Saturday and 9 to 5:30 on Sunday. So myself and Rob and colleague Stuart will be taking shifts over that time. Any other questions? Does anybody want to? I can see Thomas. See you typing. Rob, is there anything else you want to add?
No, I don't think so. Yeah, just look forward to seeing what you can all make of this next weekend.
Yeah, that's really exciting. Just wait, see if Thomas. So who will be the judges? I think it's a joint decision between GSI and KCL Space. And the internship is for 2 months, and it may be remote or it may be in person. At the moment, we are all working remotely, but we would hope to have an office, return to the office by summertime, I would expect. But the world we're living in just now is quite unpredictable. Is the grading based on the pitch quality or the technical solution? Thank you, Thomas. The answer is both. So we need to assess both those two aspects. So it's up to you how you want to balance your effort, and but it will be covering both of those aspects. Okay. All right, folks, I think we'll stop there. And once again, thank you for your time and all the best of luck. And maybe we'll speak to you or type some messages on Discord with you next weekend. and hopefully this is a really exciting challenge, and we're really looking forward to seeing what you come up with. And all the best of luck, and speak to you soon. Thank you for your time today, folks.